amazing students. This is Mrs. A, and I love math. Well, I'm not in my normal setting today. I am at my daughter's house, and I am enjoying my brand new grandson, and his name is Timothy Allen, and he's pretty fine. So I'm having a lot of fun holding a baby a lot. But I needed to stop holding the baby long enough to make your video for you tomorrow. So this is Tuesday night and your class is Wednesday, so I had to get busy and make your video. So we're learning lesson 14 today, so I want you to make sure that you have your notes out, you're ready to take notes, and we're talking about evaluation of expressions and maybe some formulas. Okay, so we're going to learn some vocabulary first. A letter that represents an unidentified number is a variable, and an expression is when we put a variable with some other things like constants or other variables. It can become an expression. So 4s is an expression, and it means 4 times s, which means the same thing as 4 times a number, s, that we don't know what it is at the moment. And s is the variable in that expression, and 4 is the constant in that expression. So a formula is an expression of the or equation used to calculate a desired result. Okay, so here is one. This is one that maybe you recognize. Perimeter of a square is 4 times s. In this case, s stands for the side length, because wouldn't a square have 4 sides that are the same? And so if you were talking about the perimeter, which is the distance around the square, wouldn't we add the side length? We'd multiply by 4 or add all 4 sides together. Since they're all the same, it would be 4 times the side length. So when we evaluate an expression, we do that by plugging in the value that they give us in place of the variable. So as an example, example 1 says a formula for perimeter of a rectangle, I'm using some shorthand here because I want to get back to that baby, is P equals twice length plus twice width. So the perimeter of a rectangle is twice the length, I'm going to add those two together, and twice the width, right? Well, then I can evaluate that perimeter when they give me the length and they give me the width. So I have a length of 15 centimeters and a width of 12 centimeters. So to find the perimeter, I'm going to plug those two values in here. So here we go. Okay, so I got myself some room to work here now. So we're going to have P equals twice length. So twice, I'm going to take out the L and I'm going to put in the 15 because L in this problem stands for 15. Then plus twice the width. And I'm going to take out the W and I'm going to put in the 12. That's what we mean when we say evaluate. So 2 times 15 is 30, plus 2 times 12 is 24. So wouldn't the perimeter equal 30 plus 24, which would be 54, okay? So 54, in this case it was centimeters, 54 centimeters would be the perimeter of that rectangle. Okay, a little bit more vocabulary. An equation is a mathematical sentence stating that 2 quantities are equal to each other, okay? So a solution to an equation is a number that makes the equation true. So here we are on our last example. This is a very short lesson. So that kind of worked out nicely since I had to be gone. But example 2 in your book says, if you have, let me read it to you, okay? It says, if a taxi company charges a $2 flat fee plus $3 per mile traveled, then the cost in dollars of the taxi ride is shown by this formula. 3M plus 2 equals C. Okay, so that's the example. 3M plus 2 equals C is the formula. Now, when they say a flat fee, that means that's what you're going to pay just by engaging that taxi. Or you hail down the taxi cab like you see them do in the movies. You jump in, you just paid $2, whether you go anywhere or not. That's what a flat fee is. It is regardless of the money that you, the distance that you drive, you will pay that $2. Okay, so now, and then for every mile the taxi goes, you're going to pay $3 per mile. So this is the formula. So then it says, if the cost for the ride is $20, then find the length of the ride. So we're going to put right here, cost of the ride is $20. Okay, so now I'm going to try to find out how many miles did I travel. I'm paying $3 for each mile, and I paid $2 just for jumping in the taxi, and the total ride was $20. Well, can I take 2 away from both sides? So I'm going to take 2 away and 2 away. So now I have 3M over here equals, this goes out, 20 take away 2 is 18. So I have 3 times the number of miles is 18. But I want the number of miles, which is what M stands for. So I will divide each side of the equation by 3. I always do the same thing to both sides of my equation. And then I end up with M equals 6. I went 6 miles in that taxi, and my fee was $20. Okay? So now we're already on our practice problems here. So let's look at A. I'm going to read A to you. It says a formula for the area of a parallelogram is A equals BH, which means area equals base times height. Find the area of a parallelogram with a base of 12 inches and a height of 4 inches. Okay, now if you look at the little picture in your book, they have down here 12 inches, and they're showing the straight drop of the height to be 4 inches. It's always the straight drop down. It's not what we call the slant height. We're talking about the straight drop down, and that I want to show you something that maybe will help you make a little bit more sense to this. What would happen if we shaved off that little triangle? We did a straight drop down, we shaved that little bit of a triangle off, and we went and stuck it right there like a puzzle piece. Wouldn't you have a rectangle? And wouldn't the rectangle be the same length because you took off that piece here, but then you stuck it in over there? So wouldn't the rectangle have the same base as the parallelogram? And a rectangle's area is base times height. And now a parallelogram's area is base times height, but they're not talking about the slant height, they're talking about the straight down height. And that's because a parallelogram can very easily be turned into a rectangle just by slicing off a little triangle and putting it over there on the other side like a puzzle piece. Okay, so now area is base times height, and then they're saying, what if the base were 12 and the height were 4? So we're going to evaluate the area based on these 2 variables that they gave us. So instead of B times H, I'm going to put B, which was the base, which was 12, times H, which was 4. And 12 times 4 is 48. Now, this is area. Remember, with area, we always use square units. So 12 times 4 is 48, But instead of inches, it is square inches because we are doing area. Okay, so here we have B, and B says in the expression for AC, what is the constant? And the constant is the numeral value that's in the front. We usually put constants in front before the variables. In this case, we have two variables, A and C, and 4 is the constant. And if we were going to evaluate, we would multiply them all together. And C says, evaluate for AC for A equals 1 and C equals 12. Okay, so they gave us the expression for AC. So we're going to rewrite for AC, and we're going to put A is 1 and C is 12, and we're going to multiply them all together. So 4 times 1 times 12 is 48. So the answer is 48. This is a pretty easy section, isn't it? Okay, D says solve by inspection. Now, solving by inspection simply means looking at something and maybe making a good guess and checking it out to see if it's right. So if we were going to look at W plus 5 equals 16, we know there's several ways that we could do this. We know that when we have an addition equation, we could undo it with a subtraction equation. So if something plus 5 is 16, then doesn't it mean that 16 take away 5 is W? That would be one way to solve it by inspection. You're just saying, okay, subtraction undoes addition. You could do that. Another way to do it is just to regularly solve it by just saying, oh, I want to get this by itself. This guy's bothering me, so I'm going to get rid of him. Minus 5. Okay? And W equals 16 take away 5, which is 11. Now, isn't that exactly what we had when we said if W plus 5 is 16, then to undo that, we go backwards. 16 take away 5 is W. 16 take away 5 is W. You're going to get the same answer, aren't you? Okay, so more solve by inspection. We're on letter E now. Okay, so we have M minus 6 is 18. So subtraction and addition undo each other. So we could say M minus 6 is 18, so 18 plus 6 is M. Well, 18 plus 6 is 24, isn't it? Okay? Or we could do it by just saying I'm trying to always get my M by itself. So I want to get rid of a minus 6. To get rid of a minus 6, I add 6. And I add 6. We know that opposites add to each other to get 0, don't they? So now this goes away. 18 plus 6 is 24. M is 24. Okay, so let's do this one two ways. 25 take away N is 11. Okay, so 11 plus N is 25. Neither one of those is really easy to take care of, but we know that 11 plus N is 25. So if I know that N is going to get 11 to 25, couldn't I say 25 take away 11 is going to be that number, isn't it? And 25 take away 11 is 14. Okay, so let's try it. Let's plug 14 right here. 25 take away 14 is 11. It's true. It works, doesn't it? Remember that a solution is something that makes an equation true. All right, so here we are on G. 5 times X equals 30. So remember when we see a constant times a variable right next to each other, we don't put a symbol in there between. Not usually. Okay, so 5x means 5 times x. Well, how do you undo multiplication? You divide. So we're going to divide this side by 5. I'm going to divide this side by 5. And we're going to get x equals 6. So let's try it. We did 30, divide by 5 is 6. So let's put the 6 right here. And let's see if it makes the equation true. 5 times 6 is 30. It works, doesn't it? Okay, these are pretty fast. H says D divided by 4 is 8. Something divided by 4 leaves us with 8. So why don't we undo the division problem with multiplication? Remember, we go backwards on it. 8 times 4 is 32. Well, let's check and see if 32 makes the equation true. So let's put 32 divided by 4 is 8. It works. Therefore, D must be equal to 32. Letter I says 12 divided by Z is 6. Okay, so if 12 divided by Z is 6, then isn't 6 times Z equal to 12? 6 times what is equal to 12? 6 times 2 is equal to 12. So Z is 2. Okay, so inspection is when you can kind of do it in your head, reason it out. So now we're going to plug in the 2. 12 divided by 2 is 6. It works. Therefore, Z is equal to 2 is the solution for that problem. Okay, so now this is J, and it says 2a minus 1 equals 9. Okay, this one's getting a little bit more complicated. Remember, we're trying to find out what the a is. Let's get rid of the 1. Now, we could go backwards on this one. We could say, well, that's subtraction, so 9 plus 1 equals 2a. 9 plus 1 equals 2a. Well, I know 9 plus 1 is 10, so I get 10 equals 2a. Well, if 2 times a is 10, then 10 divided by 2 is 5. So let's see if 5 works. Okay, twice 5 is 10. 10 take away 1 is 9. And that works, doesn't it? A solution is a number that makes an equation true. So I brought you a little treat to see my new little grandbaby. Isn't he fun? Oh, he's grabbing my finger. This is Timothy, and he wants to go be with Mommy. But I wanted you to see him. I'm having lots of fun with him. Okay, so K says 20 equals 3F, take away 1. So we have to do this by inspection. We're trying to get F. What if we just added 1 to both sides? So if we add 1 and add 1, won't that make things a little bit easier? So 20 plus 1 is 21, and the 1 and the negative 1 disappear, and we end up with 3 times F is 21. Oh, that's much easier. 3 times something is 21. I bet you know that in your head. The answer is 7, right? And 21 divided by 3, remember, division and multiplication undo each other. So the answer is 7. So now let's check it. Let's go with 7 back up here and see if it works. 20 equals 3 times 7, which is 21. Take away 1. 21 take away 1 is 20. And that's what makes it true. So the solution is 7. L is our last practice problem. Okay, so it says here, admission to the county fair is $3. Each ride cost $2. Nate has $15. Solve the following equation to find out how many rides he can make. Now, they give you the equation in the book, but I want you to see if we can reason out what the equation is. It cost Nate $3 just to walk into the gate. He's got to pay $3 at the door, doesn't he? At the gate. So $3 to start with. And then it takes him $2 for every ride. So let's let R be the number of rides. So 2 times R, $2 for each ride, equals, and he has $15 in his pocket. Now, that's not much different from the equation that they gave you in the book. In the book, they gave you 2R plus 3 is 15. But we've learned about the commutative property, and 2R plus 3 is exactly the same as 3 plus 2R. So both of them are correct, right? So now, let's see if we can figure out. First of all, if he has $15, it took him $3 to walk in the door. So if we take away the $3, 15 take away 3 is 12. He has $12 left to spend on rides, but each ride costs $2. So what's 12 divided by 2? What's 6? He can ride 6 rides. Okay, so let's plug in 6 right here. 3 plus 2 times 6, 3 plus 12 is 15. And it works. We are on problem number 1 of our written practice now. So we're almost done with this lesson. Number 1 says, there were 256 farmers in the county 30 years ago. 5/8 of those farmers have changed their occupations. How many of the 256 farmers changed occupations? So 5/8 changed, and they're asking how many have changed. So isn't the question 5/8 of 256? Won't that give us the answer? And remember that of is times. Anytime we see of, it's times. All right, so we're going to have to do a little bit of work. Let's get another board. Okay, so remember when we're multiplying a whole number by a fraction, the easy way to do it is see if the 8 would go evenly into the 256, and it does. 8 goes into 25 3 times. 3 times 8 is 24. Take away 1 and bring down the 6. 2 into 8, 8 into 16 is 2. 32. So 32 is 256 divided by 8. So now won't we multiply the 32 times the 5? 32 times 5. 2 times 5 is 10. 3 times 5 is 15. 16. 160 farmers changed their occupation. Now let's see, does this make sense? Now remember, 5/8 is a little over half, isn't it? 4/8 would be half. So 5/8 is greater than half the farmers. And isn't 160 greater than half of 256? So half of 56 is 28. Half of 200 is 100. 128 would be half the farmers. 160 is going to be 5/8 of the farmers. Okay, so here we are with written practice number 2. It says averaging 35 pages per hour. How many pages can Karina read in 2 hours, 3 hours, 4 hours? This is one of those easy ones, isn't it? All right, so she reads at 35 pages per hour, which means every 1 hour she reads 35 pages. So when we take 35 and multiply by 2 to have 2 hours worth of reading. So 2 times 35 is 70. 3 times 35 is going to be 105, and 4 times 35 is going to be twice 70, which is 140 pages. Okay, so that was pretty simple. Number 3 says, each package of light bulbs contains 4 bulbs. If an employee at a construction office needs to order 480 bulbs, how many packages should she order? Okay, so we have 4 bulbs per package. We need 480 bulbs. How many packages should you order? Okay, so if you order 1 package, you get 4 bulbs. If you order 2 packages, you get 8 bulbs. Shouldn't you take your 480 and divide it by 4 to get the answer? Okay, so we're going to say 4 times the number of packages that will give you the number of bulbs is 480. Okay, when you try to make an equation out of it, it gives you the answer, because in order to undo multiplication, we divide. 480 divided by 4 gives us the number of packages. Well, 480 has 4s all over the place, doesn't it? 480 divided by 4, 4 goes into that 1 time, 4 goes into that 2 times. It's 120. And we're going to stop right there because that's our answer. 120 packages times 4 gives us 480 light bulbs. Okay, so number 4 says, when Betsy Ross made the American flag, it had 13 stars. On July 4th, 1960, the 50th star was added to the flag for Hawaii. How many more stars were on the flag by July 4th, 1960 than were on the Betsy Ross flag? Okay, well, if the Betsy Ross flag had 13 stars, and when Hawaii was added, it was the 50th star. To find out how many more stars were added, don't we just take 50 minus 13? And 50 minus 13. Well, I don't have room to do this vertically, so let's just do it horizontally. I know that I'm going to need 0 take away 3 doesn't work, so I'm going to take 1 away here and make it there. 10 take away 3 is 7. 4 take away 1 is 3. We have 37 more stars on the flag. And number 5 is our last practice problem, written problem that we're going to do together, and then you're going to go do the rest of it by yourself. 15 is m minus 4, okay? Doesn't that mean that 15 plus 4 would be the number we're looking for? Okay, a number take away 4 is 15. So if I want to go backwards on that, it would be 15 plus 4 is 19. So let's try 19. 15 equals 19 take away 4. Yes, so 19 is the solution. Okay, now the formal way to work that problem would be to, since we want to get rid of the negative 4, we add a 4 here, and we add a 4 over here. This goes away, and we get m equals 19. That's called the addition property of equality, which we'll be learning very soon. And we are done with lesson 14. And now it's time for you to do your homework. I hope that you're keeping up with things in my absence. And I'm going to go play with that grandbaby a little bit more, and then I'll be home to teach you your lesson on Friday. This is Mrs. A, and may God bless your day.